I'm Anil Kumar sharing with you a new series on calculus which will help many of my students to get excellent marks in school and also prepare them for getting admission to the best universities or institutes. So today is February 9th, 2018, and the aim is basically to help you out. Some of you have taken AB Maths, AP Calculus or AB Calculus. Most of you are working for entrance examinations like IIT JEE or applying to foreign universities, right? So this is very helpful for all of you. You can search Anil Kumar IIT JEE playlist for related videos. Now let me thank all my viewers and subscribers. I have more than 10,000 videos and many subscribers, and every day I do get a lot of requests from students. At present I am able to cope up and provide them with solutions in 48 hours, but soon it will be very difficult for me to cope up with the current demands. So therefore I'm looking forward for donors. I'd like you to generously contribute so that we could continue and provide free resource for all the learners worldwide. Well, so let's begin with the topic. I've taken up limits in this particular series since I'm also at a limiting point. Now, in this particular series, we'll take up limits, and these are the examples which we are going to work with. As an IITian myself, I will share with you how we can prepare ourselves to do well and get into the best universities. Now, remembering formulas and spitting them out is definitely not what you should be doing. So what I will do here is that with every question, I'll give you formulas also. Like here, we have 4 questions based on limits, and you could actually solve them by factoring. A cube minus b cube or a cube plus b cube formula can help you. Those of you who are already at an advanced level could use that limit x approaches a for x to the power of n minus a to the power of n divided by x minus a is equal to n times a to the power of n minus 1. So I'll provide you proof for all the hints which I am giving also in this series in the form of few links, right? Now doing all that on YouTube is very difficult. So I want to develop a website where it could be more interactive and useful for the students, and for that I need your contribution. So looking forward, so you can always email me and then we can work it out. Okay, so let's get back to this series. We are going to discuss such multiple choice questions which I'm showing you here one by one, right? So these are the questions which you need to answer after you do all these videos on limits. Now they have been taken from previous test papers and competitive exams. So they are not easy, right? Especially this one, pretty difficult, right? Have a look. You can always pause the video. Multiple choice questions do not really mean that they have to be answered in 30 seconds. Let's be very clear. Some of them might take 10 minutes, okay? So there are different levels. For example, when we talk about AB calculus, you are given enough time to do these questions. At times, you may be allowed graphing calculator also. But in my examples, we'll do without graphing calculator. Now, these are the questions which we discussed in the very first page, which we'll answer one by one, correct? Now, here is the first question on limits level 2. We need to find limit when x approaches 9 for x to the power of 3 over 2 minus 27 divided by x minus 9. Now, we could always write this as limit x approaches 9. Since we have x minus 9 in the denominator, we could actually write the numerator also in terms of x and 9. So I could write this as x, that is square root, right, cube minus 27 is 3 cubed, right? So I could write this as square root of 9, which is 3, and then cube it, right? So that gives me x to the power of 3 over 2 minus 27. And now we need something in square root of x and square root of 9. So I could write the denominator as square root of x whole square minus square root of 9 whole square. Now square root of x whole square is actually x, since we are approaching a positive value. Otherwise, you should remember that square root of x square is absolute value of x, right? Okay, so I hope the first step is very clear. Now, we have difference of cube in the numerator. We have difference of square in the denominator. Some of you may remember difference of cube formula is a cube minus b cube equals to a minus b times a square plus ab plus b square, right? If it is plus, then this value is plus and that is negative. So we'll apply this particular formula to factor it, right? So we could write this as equal to limit x approaches 9. When you say a minus b, a is square root of x. So we have square root of x minus square root of 9, that is a minus b, times square of this. So square root of x is just x, right? Product of these two with a positive sign, that means product of 9 and x, right? These two. Plus square root of 9, which is 9. Do you get an idea? Divided by, we have x square minus, square root x square minus 9 whole square. So this is difference of squares, which I could write as product of sum and difference, right? Product of sum and difference. Do you see that? Now I hope you appreciate why we wrote everything as square root and then square, right? You see a factor which can be cancelled. The whole idea is, when you begin solving these questions, if I substitute 9 here, I get 9 to the power of 3 over 2 is 27. 27 minus 27 is 0. So substituting 9 gives us 0 over 0. That really means x minus 9 was a factor in the numerator, right? We call them indeterminate. So I'm just reminding you a few terms which you already know since we are working calculus level 2. So we learned all this in level 1, correct? Now, what do you see here? Let me rewrite this on the right side. So the limit basically is limit x approaches 9, and we are left with x plus square root of 9 times x plus 9 over square root of x plus square root of 9. Now, since we have cancelled these factors, which was making denominator and numerator 0, we can substitute x equals to 9. So if you do that, what do you get? You get 9 plus square root of 9 times 9 plus 9 divided by square root of 9 plus square root of 9, correct? And that is clearly in the numerator 9 plus 9 plus 9. I could have written 3 times 9, and this is 2 times square root of 9. Do you see that? That is what you get at this stage, correct? Square root of 9 is 3. So we could write this as 3 times 9 and the denominator as 2 times 3. So now we can cancel 3 and 3, right? So all these exercises should be done without calculator, and you get your answer, which is 9 over 2. So the limit of this function as x approaches 9 is 9 over 2, right? Let's take the next video, which is, we'll now find limit x approaches 2 for x minus 2 divided by cube root of x minus cube root of 2, correct? We'll apply similar factoring technique as we did last time. So this could be written as limit x approaches 2. Now, we basically want cube of something, right? X could be written as cube root of x whole cube. Does make sense to you? And 2 could be written as cube root of 2 whole cube. Denominator, we already have something which is cube root. Okay. Now, I'm adopting a very different technique to solve these questions so that we learn a method and we can apply this method over and over again to solve such questions. Numerator is difference of cubes. So again, I will expand this as this formula, correct? With this formula. So we get a minus b, which is cube root of x minus cube root of 2a minus b times a square, that means cube root of x square plus product of these two, which is cube root of 2x, just multiply x with 2, plus square of the next term, which is cube root of 2 square. Now, at times it becomes difficult to work with radicals. I hope with the examples I've taken up, that should not be so difficult. Okay, we already have a term which is cube root of x minus cube root of 2 in the denominator. Clearly, these two terms will cancel away. So when they cancel out, you could write this as limit x approaches 2, numerator is 3, cube root of x whole square plus cube root of 2x plus cube root of 2 square, right? So that is what you get in the numerator. Now we can actually substitute 2 and get our answer. So I hope the steps are very clear to you. Why did we do all this factoring? Since in the numerator, substitution of 2 gives you 0 over 0, right? And therefore, it is also a case of indeterminate. We need to rationalize, we need to factor, or we could use some other rules, which we'll learn soon. Correct. Let's substitute and then see what do we get. So we get cube root of 2 whole square plus cube root of 2 times 2 plus cube root of 2 whole square. That means we have got three similar terms, which is 3 times cube root of 2 square, right? Well, you could write this as 2 square is 4, correct? 2 square is 4. So you could either write this as 3 times 2 to the power of 2 over 3, right? You could do that. Or you could write cube root of 4 anyway. So we know this limit is actually 3 times 2 to the power of 2 over 3, right? So I hope it helps you to understand how we can do such questions. I'd like you to pause the video now and answer this question on your own. However, I'll teach you a different technique while doing a similar question, right? Now, in this particular video, let us see how to find limit when x approaches 0 for x plus 8 to the power of 1 over 3 minus 2 over x. If I substitute 0 here, what do I get? Cube root of 8 is 2, 2 minus 2 is 0, 0 in the denominator. So again we get the form 0 over 0, which is indeterminate. That clearly shows that we have a factor x in the numerator also that we could factor out using different techniques. Now in this particular part of the video, we will learn substitution also, right? So substitution. What you could do is that you could substitute x plus 8 as some other variable, let's say u. In that case, x will be equals to u minus 8, right? And also the limit as x approaches 0, u approaches what value? If x approaches 0, u approaches 8. And therefore, I could rewrite this question as limit u approaches 8. Substituting x plus 8 as u, we get u to the power of 1 over 3 minus 2 over x is u minus 8, correct? So that becomes your question to be solved. I'd like you to pause the video, solve this particular question. You may use this formula and then get your result. So let's do it. So now we are solving the question limit u approaches 8 for u to the power of 1/3, that is cube root of u, minus 2. 2 could be written as cube root of 8. And in the denominator, we have u minus 8. Do you see that? Now, if I want to use a cube minus b cube, I could actually directly use it. But for simplicity, let me say we cube this and then we cube root it. Similarly, we cube this and we cube root it. So it's the same thing, u minus 8, right? However, this strategy helps us to factor the denominator, right? Let's see how. So here we could write this as limit u approaches 8. In the numerator, we have cube root of u minus cube root of 8. And in the denominator, we have u cube, cube root cube, 8 cube root cube. So we have difference of cubes, which I could write this as cube root u minus cube root 8 as the first factor. The other one is square of these. So square root of this plus product of these, that is cube root of 8u plus square of this one, right? So square of this one. Now you can see there is a common factor which could be cancelled. That's the whole idea. So we are doing this process over and over again so that you understand this strategy and it helps you to solve difficult questions. So what we have here is cube root of this square plus cube root of 8u plus cube root of 8 square. Now I can substitute u as 8. So what do I get? I get 1 over cube root of 8 square plus cube root of 8 times 8, which is 8 square, plus cube root of 8 square. Clearly, it is 1 over 3 times cube root of 8 square, correct? So that is your result. So your result is 1 over 3 times 1 over, now you could write 8 cube root as 2, right? So it is 2 squared. Do you see that? 8 cube root is 2. So you get 1 over 12 as your answer. Does make sense to you, right? So 1 over 8 is your result for this particular question, correct? So let's move on and take more examples based on the similar strategy. So this time we have, as x approaches y, x to the power of 3 over 2 minus y times square root of y over x minus y. Now here you could rewrite this as limit x approaches y. Now this is like square of, or let me write like this. We have square root of x, that is 1 over 2, and then we have a cube here. Do you see that? And this one is also y to the power of 3 over 2. So I could write this as square root of y cube. Correct? Let's see. Why am I writing like this? Y times y to the power of half. So you add them up, right? So 1 plus half is 3 by 2, right? So 3 by 2. Square root is by 2 and that cube. So anyway, you have difference of cube in the numerator again. Denominator, I could say difference of squares, right? So let me write like this. Square minus square root of y square. Just to tell you that we could always apply these formulas in such situations. So what we get here is limit x approaches y. This is square root of x minus square root of y times square of this, which is just x, plus product of these two, that is product of xy plus y, square of square root y. And here we have square root of x minus square root of y times square root of x plus square root y. Correct? So I hope by now you are an expert on this method. So that results into writing this equation as limit x approaches y for x plus square root of xy plus y divided by square root of x plus square root of y. Now we can substitute x equals to y. Earlier we could not do it since it was 0 over 0, right? So let's substitute and then see what do we get. So x as y gives us y plus square root of y times y plus y, that is 3y's, right? And here we have square root of y plus square root of y. That means, so we have 3y's in the numerator and 2 square root y's in the denominator, correct? Let me just... So that gives you the idea that it is 3 over 2 square root y. Does it make sense to you? So that becomes the limit of the given question in this particular case. So we have solved most of the questions. I think we have solved all of them. And we have some more to go. Well, that's an identity which we'll prove in next part of the video. I hope the concepts are clear to you. So we had been taking up this identity as an advanced function. You must have seen it right at the end of my videos. So when we began with, we gave you this kind of a hint. So we are saying that at advanced level, you could also use limit x approaches a for x to the power of n minus a to the power of n divided by x minus n is equal to n times a to the power of n minus 1. You could use this formula to answer the 4 questions which we just now did. So take it as an exercise, and in part 2 of my videos, I will actually prove this identity first and take up more multiple choice questions which will help you to review the concepts learned in this video. I'm Anil Kumar, and I hope that helps. Feel free to share your views and comments. If you like and subscribe my videos, that'll be very good for me. Thank you for all the encouragement and help. Thanks a lot.